Okay, we're going to have a brief introduction to Chapter 1. We're going to go over in this video sections 1 and 2, which basically talks about whole numbers and adding and subtracting, estimating, how to read whole numbers. And so let's get started. What is a whole number? That's going to be important. Let me mention that you can find these blank notes in the content section under Blackboard, under Chapter 1, if you want to follow along with me and take your own notes. So, what is a whole number? Well, whole numbers are those numbers that you learned in kindergarten, right? Like when you started counting 0, 1, before we knew that there were decimals. They go on forever. Okay, so sometimes whole numbers can get really big and we need a way to kind of group those together. For instance, if I ask you, well, how many letters are shown here? Well, I kind of need to come up with a way to, because it's really hard to estimate what's here with them being everywhere, turned all different ways. So maybe if I divided them into groups of 10, like there's 5, and there's 5, so there's 10. So now I know there's 10. Let's see if we can find another group of 5 and 5, which would be 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10. And then we can tell we've got these 3 others that are just hanging out up there, okay? And so when we were designing our number system and how we would come up with things, we kind of knew that we needed to talk about numbers and be able to break them down. And so that's really what expanded form is. So if I want to talk about 46, I could break it down into 4 groups of 10, which is 40, plus 6. If I want to talk about 874, I could break it down into 8 groups of 100, 7 groups of 10, and 4 ones. 305, I can break it down to 3 hundreds. I don't have any 10s because there's 0 there, so plus 5 ones. Only 10 numerals are needed for our number system, 0 through 9, and every number is made of those. So the digits 4 and 6 are used to write 46. The number 874 is a 3-digit number, so on. So place value. Notice that the 2 in 762 means something completely different than the 2 in 425 and 208. Because in 762, the 2 signifies 2 ones. In 425, the 2 signifies 2 tens. In 208, the 2 signifies 2 hundreds. This is our place value system. And it's important that we talk about our place value system because it's how we communicate about numbers, how we read on how we write them. Okay, so if I want to read this number, we kind of go up here and we start backwards. So if I want to come up here and say, okay, I've got 7, 3, 2, 4, 1. Now it's important that you know that the commas separate everything, and so before we get to the comma, we kind of ignore everything after it, and we say, well, if that number is just by itself, how do we read that? Well, we would just say 14. Okay, but the important part is there is a comma there, and so because there's a comma there, I need to look up at my place value, and I have to read that. So it's actually 14,000. Okay, then I'm going to look at my second group of numbers. I'm going to read that and ignore the 14, and so that would be 237. Now we know that the 7 is in the ones place, so we don't have to put 37 ones, 237 ones. We don't put that, okay? Let's look at this number. This looks crazy. So we've got, I always back up. So we've got 866, right? back up, just writing the number up here. Okay, now you're going to start this way. We know that we read that 47, but 47 what? Because we got a comma. And so we have to look at the 7 and say, oh, the comma is in the billions place, so 47 billion. Okay, next, we're going to look at the next three numbers. We would write just what we see. So 600, ignore everything else, 53. Okay, but the 3, right? The 3 is in, there's a comma after it. So I have to go, okay, what is 3? 3 is in the millions place. So it's going to be 653 million. Okay, next numbers. 290. Okay, comma. So where is my 0? My 0 is in the thousands place, so 290,000. Okay, now the last part, 866. And remember that the 6 is in the ones place, so you don't have to put anything after it. So that's what we do to communicate with other people about really large numbers. We have a number system. So in each block of 3 digits, read the digits in the normal way, just like we just did. And notice that the word and is not used in naming these numbers. In many situations, especially in tech math, it's going to be important that you can talk about big numbers and round them. In other words, if you had an accountant business, sometimes you want to be able to refer to things as the exact number, and sometimes you're going to want to talk about something as being a general number. And so if we take this number 247,563, and I said, well, I really want you to round that to the thousands place. Okay, let's look at a couple of different things. Let's round it to the thousands place. Let's round it to the tens place. Let's maybe round it to the hundreds place. Okay, so if I told you to round this number to the thousands place, well, the thousands place value is right here. So if I'm rounding to the thousands place value, I automatically know that everything after that is going to turn into a 0. I'm going to keep the numbers the same that are before it. Now I'm going to have to make a decision about that number, and I'm going to say, okay, look next door. That is 7. If this number that's next door is greater than or equal to 5, we're going to need to round up. And guess what? 5 is equal to 5, so that means the 7 is going to turn into an 8. This would be rounded to the thousands place. So if I take the same number and I said, well, I want you to round it to the tens place. Well, the 6 is in the tens place. So the numbers before the 6 stay the same. The number after the 6 turns into a 0. Well, what happens to the 6? We look at the number behind it. If that number behind it is 5 or bigger, we would round up. But 3 is not 5 or bigger, so we would leave it alone. Okay, if I want to take the same number and I want to round it to the hundreds place, well, the 5 is in the hundreds place. The numbers before it would stay the same. The numbers after it turn into zeros. And we decide what happens to the 5 by looking at the number behind it. Is 6 5 or bigger? Yes, it is. So then that means we round this number up to a 6. Okay, so there's going to be times when you're going to want to just be able to talk about a general, broader view instead of the exact answer. And that's when rounding comes into play. So a lot of times when we're talking about addition of whole numbers, you're going to hear the word sum. So if I want to talk about adding 31 hours and 48 hours, it's really smart to go ahead, even if you have a calculator, and just get a rough estimate, because you could always type something in wrong. So basically, they come over here and they said they took 31 and made it 30, because 31 is closer to 30 than it is to 40. 48 they made into 50, because 48 is closer to 50, and then they've just added and got 80 hours. So if I was on a job site, I could do that pretty quick in my head. Okay. If you'll notice how we're adding them, we're lining them up with the ones place and the tens place. So we've got an 8 and a 1. That's going to give me a 9, a 4 and a 3. And then I want to kind of compare these two answers. Okay, so is 80 hours close to 79 hours? Yeah, which helps me to realize that I'm on the right track and I've got the right answer. Always a good idea to get a good estimate. Okay, so let's look at this. What would you what would you take 27 to be if I was going to estimate it? Closer to 30 than 20? Okay, 58 would be closer to 60 than 50, and if you add that, we would be talking about 90 pounds. If we want the exact answer, 27 pounds plus 58. Now I'm lining up the ones and the tens. 7 and 8 is going to give me 15. Carry the 1. 5 and 2 and 1 is going to give me 85. 90 pounds, 85 pounds, that's pretty close. So I'm probably on the right track. Okay. We've got a little bigger problem. So the 536, most of this was in the biggest numbers, hundreds, thousands, hundreds. That's really close to 100. So let's round these to the hundreds place. This will be closer to 500 than 600. This will be closer to 1500. 875 is going to be closer to 900, and 88 is going to be closer to 100. Well, 500 and 1500 is 2,000. 900 and 100 is 1,000. So this, if we rounded, we would get 3,000. Now let's line this up. So 536, 1473, 875, 88. Okay, 6 and 3, 9. 9 and 5, 14. 14 and 8, 22. So we put the 2 that's in the ones place, but the 20 part of the 2 has to get carried to the tens place. So 5 and 7, that's 12. 12 and 7 is 19. 19 and 8, 27. Carry your 2. 2 and 5 is 7. 7 and 4 is 11. 11 and 8, 19. Carry your 1. So 2,972. Okay, are those numbers pretty close? Yeah. It's important to estimate, especially if you're doing some practical math like engineering or technology in any kind of trade. A successful builder, painter, or repair person must make an accurate estimate of job costs. Sometimes their business depends on it. If you work in a technical trade, getting and keeping your job may depend on your ability to get the correct answer every single time. If you use a calculator to do the the actual arithmetic, it is even more important to get a careful estimate of the answer first. It's so easy to just type in the wrong number, so we have to be careful about that, and getting that estimate just kind of helps. Okay, in order to make and accommodate the weight of their vehicle, we've got the California Highway Patrol is now using an SUV instead of a sedan as their primary vehicle. So they've added some equipment. They've got a 54-pound push bumper, a 12-pound computer. They've got a tub that carries their rifles and their rifle's 32 pounds light bar, a prisoner barrier, video equipment, and some traffic cones and some other supplies. So that's a lot. So if I wanted to come up with an estimate for 54, probably call that 50. We got 12, 10, 32, be closer to 30 than 40. 30 is already estimated. 56, 60, 270, already estimated 50. Okay, now this can be pretty overwhelming pretty quick, but I'm looking at this 30 and this 270 and I'm going, well, that's 300. That was easy to kind of come up with. Let's break that down. So I also have a 50 and another 50. Make that 100 pretty quick. And what else we got left? We got a 60 and a 30, that's 90, and a 10, which is 100. So now I can see that that's 500. Okay, so I could come up with, well, it's approximately 500. Now, if I want an exact answer, remember we have to line these up. So 54, 12, 32, 30, 56, 270, 50. And it's not that this is that hard to do. It's just harder to think about these numbers sometimes whenever you're having to get the exact answer. So 4 and 2, 6, 8. We've got 4 and 2 is 6, 8. 6 more is going to be 14. Carry our 1. This is not supposed to be a 6, so I'm going to fix that. Okay, now we've got 1 and 5 is 6, 7, 10, 13, 18, 25. It's going to give me a 30. So put your 0. Carry your 3. 3 and 2 is going to give me 5. Those answers are right on. So units of measure. Units of measures are important in every trade, just as you want to make sure that the customer is not thinking in centimeters while you are thinking in yards. You will want to make sure that your measurements required for projects have consistent units. So this is going to give you some examples. If we talk about length or distance, we're mainly using these. These are our US units compared to our metric units. If we're talking about weight, ounces and pounds, or micrograms, milligrams, area, capacity, or volume. You might want to look over those. And then we've got speed and temperature and power and energy, heat, pressure, amounts per number. So those are for your reference. Okay, so what is subtraction? We've talked about addition a little bit. What is subtraction of numbers? Well, it's the reverse of addition, right? If we were going to do 3 plus 4, we would get 7. Well, to subtraction is 3 plus what gives me 7? Well, to figure that out, right, we would do 7 take away 3, and that would give us our 4. The difference is the name given to the number. I'm sorry, the difference is the name given to the answer in the subtraction problem. So, here's a more difficult subtraction problem. Should we start out with an estimate first? 47, probably round that up to 50. 23 is closer to 20. So, say estimate of 30. When we're doing subtraction, we can line it up the exact same way. 7 minus 3 is going to give me 4. 4 minus 2 is 24. And so, not as close before, but not unreasonable, right? With some problems, it's necessary to rewrite the larger number before the problem can be solved. So, let's do an estimate here. So if I were to, 64 is closer to 60, 37 is closer to 40, I'm going to get an estimate of 20. So we've got 64 minus 37. Well, there's a problem because you can't do 4 minus 7. Okay, so what you do is you borrow from this 6. And when you borrow, we're going to make this be a 5. But what you've actually borrowed is a 10. So we're going to put that 10, we're going to make that 4 a 14 because we borrowed one set of 10s from this 6. So 14, can I do 14 take away 7? Absolutely. And 5 minus 3 is 2. So we've got 27. 14 minus 7, 7. 5 minus 3 is 27. We're not way off, but not as close of an estimate as we were getting when we were adding, okay? Subtract 426, I'm going to call that 400 because it's closer to 400 than 500. Minus 128, we'll call that 100 because closer to 100 than it is to 200. So my estimate's going to be 300. Let's line this up. Can you do 6 minus 8? No. So you're going to have to borrow from the 2. You're going to have to borrow a 10 and make this a 16. And then we're left with only 1 in that place. So 16 minus 8. Can I do 1 minus 2? No. I'm going to have to borrow from this 4, make it a 3. So now I've got 11 minus 2. I can do that. That's 9. 3 minus 1 is 2. So I've got 298. Now that time my estimate was quite a bit closer. Okay. So a couple more examples. So 400 minus 167. Now this, when we get to this, it gets a little bit crazy because you can't do 0 minus something, and then you can't borrow from 0 because there's nothing there to borrow from. So you have to go all the way over to the 4 and make that a 3. When we make that a 3, that gives us a 10 there. Now we can borrow from the 10, make this a 9, and I'm going to write this up here. That would mean that right there is going to become a 10. Now we can go 10 minus 7, 3, 9 minus 6, 3, 3 minus 1 is 2. So our answer is going to be 233. Okay, so what happens when you got 5,006 minus 2,487? Well, you can't do 6 minus 7. You can't borrow from this 0, and you can't borrow from this 0, so you're going to go all the way back here to the 5, make it a 4, which is going to make this be a 10. Now I can borrow from the 10 and make this a 9. And that's going to make this a 10. Now I can borrow from this 10 and make this a 9, which is going to make this be 16. Now I can do 16 minus 7, which is going to be 9. 9 minus 8 is 1. 9 minus 4 is 5. When solving word problems, you must look for keywords or phrases to help you decide what operation to use. Here are some typical questions that call for subtraction. Okay, when you see what is the difference or what remains, how much is left, it's greater than, okay, so how much would you save? Those are some key words that you want to look for in word problems that you know you're going to need to subtract. So suppose we need to find the missing dimension L. Okay, so we're looking for this. Along the top of the drawing, we have the total horizontal dimension of 86. So we know from here to here is 86. We've got this little section and we've got this little section. So if I could take off this and I could take this off, then I would be able to find out the difference. So we could start by just doing 86 minus 32. Okay, that's going to give me 4. 8 minus 3 is going to give me 5. So I took 86, I subtracted off the 32. I'm looking for L. I also have to subtract off the 25. Okay, can't do 4 minus 5, so I'm going to borrow from the 5 and make that a 14. 14 minus 5 is 9. And 4 minus 2. Okay, and so 29 millimeters is going to be what L is. Now, is there a way that I could check my work? Absolutely. I could add up 32 plus L, because this plus this plus this should equal my 86. Okay, and I can check and see if it works, right? 9 and 2 is 11. 11 and 5, 16. Carry a 1. That's going to be 8, which is what I was supposed to get. So I know that that's right. When consumers purchase new automobiles these days, they are often faced with decisions of whether to buy the hybrid version of a particular car. The hybrid version usually costs more but saves money over the long run because of lower fuel costs. Suppose that a potential car buyer is deciding between a Toyota Camry and a Camry hybrid. He estimates that he will keep the car at least 5 years and then sell it. He wants to know if the hybrid model will save him money, and if so, how much. The dealer provides him with the following information. So we've got a list of what the fuel cost and maintenance fees and all that stuff is. So we can use these figures to get a rough estimate of a 5-year total cost. Okay, so basically they've taken the columns and added them up for the Camry and for the hybrid Camry. Then they took the number 42,385, which came from right here, and 4,309,975 that came from right here. It says then subtract the 5-year resale values from the results. Well, the 5-year resale value came from up here. So they subtracted those, and they've got 34,285 for the Camry, and then for the hybrid Camry, $35,975. This figure represents the rough estimates of the total 5-year cost of each vehicle. They show that if the buyer keeps the car he chooses for at least 5 years, then sells it, choosing the non-hybrid Camry will save him money. So how much will it save him? Well, take your 35,975 minus your 34,285, which is what they did right here. They got 1,690 when they subtracted those two. Okay, so that's the end of section 1.1 and 1.2, addition and subtraction of whole numbers.